Today we'll study about second derivative test for local maxima and local minima. Look at here. Second derivative test. Okay. So what is second derivative test? Let the function defined on the interval I then fx is the local maxima at x equals to c. So we are finding the local maxima at a point if f dash c equals to 0 implies your f double dash c is less than 0. Means you find f dash c, put it equal to 0, find the value of c, put in the second derivative. If it becomes less than 0, then we have a local maxima. This, which method we are following here? Second derivative test. Similarly, and fx has, this is our first point. Then second point, fx is the local minima at x equals to c if f dash c equals to 0 implies your second derivative at that point is greater than 0. So first derivative, for maximum value second derivative should be negative, and for minimum value second derivative should be positive at the point c. Achha, now third important point on this is if third point f dash c equals to 0, f dash c 0 and f double dash c means finding the value of c, again you put in the second derivative, you see less than 0, greater than 0, but here it is equal to 0, then first second derivative test fails. That means if this becomes 0, we cannot use the method of second derivative. Then use first derivative to find, then use first derivative to find local maxima and local minimum. Okay, we'll take few examples on this so that the matter will be clear to us. Suppose we are given a question, find local maximum and local minimum values of the function f. Find the local maximum and local minimum values of the function f given by fx equals to 3x to the power 4 plus 4x cube minus 12x square plus 12. Okay, let's take the help of second derivative to show whether it is, so to find the local maxima and local minima. So what is your first step? You have to find your f dash x. First derivative. How much it is? 4 3 ja 12. 12x cube. 3 4 ja again 12 x square. Then 12 2 ja 24. Okay. 12x cube. This will be 0. So 12x cube, 12x square minus 24x. Now you put f dash x equals to 0, implies 12x cube plus 12x square minus 24x equals to 0. Try to simplify it. Take 12x common, x square plus x minus 2 equals to 0. So you have to find the values of x. How to find? F dash x equals to 12x, or if you write f dash x equals to 0, implies 12x into x square plus x minus 2 equals to 0. Implies 12x equals to 0, x equals to 0 by 12, that is 0. Then x square plus x, or you can write minus 2 equals to 0. Splitting middle term we can do x square plus 2x minus x minus 2 equals to 0. Then that will give you x common x plus 2 minus 1 common x plus 2 equals to 0. This implies x plus 2 x minus 1 equals to 0. Therefore x ka value minus 2, here it is 1. So 3 values of x you got here. The c which you are taking, c means that is first minus 2 is there, 0 is there, 1 is there. 3 values you got. The c value you got now. Now f dash c, so f double dash x means derivative of your first derivative. What is your first derivative? That is 12x cube, 12x square minus 24x. This was your first derivative. So derivative ka derivative. So how much you will get here? So that becomes 36x square 24x minus 24. Okay. F double dash x, when the value of x means c, equals to minus 2. Put minus 2 here. How much you will get? Then you will get 36 minus 2 square, 24 minus 2 minus 24. So this is 144, I think. 2 square is 4, 36 4 is 144 minus 48 minus 24. Whatever result you will get here, if you add these two and subtract, that will be greater than 0. Because this is how much? This is 60, 72. So 144 into the 90 or 72, which is greater than 0. So greater than 0 means minimum value. So you can write fx is local minima at x equals to minus 2. but you are asked to find local minimum value. So let's put in the function. So therefore, local minimum value, where you will put? You will put in fx. You will put in the function. So what is the function given to us? That is 3x4 plus 4x cube minus 12x square plus 12. So put the value here, minus 2. So 3 into minus 2 power 4, 4 into minus 2 power 3, 12 into minus 2 power 2 plus 12. So how much I got here? That is 16. 16 3 is a I think this is 16 is a 48. Then 8 4 is a, this is minus 32. Then this is 48 plus 12. So this you can cancel. How much you got here? Minus 20. So local minimum 8 point minus 2. Local minimum is minus 20. So this is the second derivative method you are using finding the local maxima, local minima. Okay, first value to you put. What is your second value? At x equals to how much it is? 0. Put 0 in the where? Second derivative. F double dash x when x equals to 0. What was your f double dash x? That was 36x square. 36x square. Check how much you have got there. Plus 24x minus 24. So if I put x equals to 0, how much I get here? Then 36 into 0, 24 into 0 minus 24. So again minus 24 means less than 0. Means you have got one more local min. So this is your maximum value because negative. Your second derivative less than 0 means you have a local maximum here. So fx has local maxima at which point x equals to 0. So therefore local maximum value will put it where? We put in the function. What is our function given to us? 3x to the power 4 plus 4x cube minus 12x square plus 12. Put x is 0. This will be 0. This will be 0. This will be 0 plus 12. So maximum is 12. Okay. Then we have got another point at x equals to 1. At x equals to 1. So what is your f double dash x? Because I cannot check whether this is positive or negative. This is how much we had got? 36x square plus 24x minus 24. I think so. So if I put here 36 into 1 square, 24 into 1 minus 24. So again you got how much? Now 36. This is cancelled. So again greater than 0. So greater than 0 means fx is local minimum value. Fx is local minimum value at which point x equals to 1. So find out local minimum value that put in the function. So therefore local minimum value fx is how much? Fx is 3x to the power 4 plus 4x cube minus 12x square plus 12. Okay, so if I put here, how much I will get? 3 into 1 to the power 4, 4 into 1 to the power 3, minus 12 into 1 to the power 2 plus 12. That is 3 plus 4 minus 12 plus 12. This gets cancelled. So that is 7. So second minimum value is 7 and the first minimum value is how much here got? I think minus 20. Okay. Now let us see. Another question on this. So find all the points of local maxima and local minima of the function. Find all the points of the local maxima and local minima of the function fx equals to how much? 2x cube minus 6x square, then plus 6x plus 5. Okay, method will be same. What I have to do? Find f dash x. So 3 to the 6 x square 12x plus 6 plus 0. Okay, then I have to make it equal to 0. F dash x equals to 0 implies 6x square minus 12x plus 6 equals to 0. How to simplify it? Then it is 6 common, x square minus 2x plus 1 equals to 0. Implies 6 into x minus 1 whole square equals to 0. This implies x minus 1 whole square is 0. Implies x equals to 1. Okay. The point C you got is 1. Now what you have to do is go to find the second derivative. What is your f double dash x? That is derivative of first derivative 6x square minus 12x plus 6. So if you put x derivative how much? That is 12x minus 12 plus 0. Now f double dash x equals to f double dash x at x equals to how much? X equals to 1. So that will be 12 into 1 minus 12. That means 12 minus 12, which is 0. So I told you earlier, if f dash c equals to 0, c gives you 1. The c value again when you put here, if it becomes 0, means f double dash x or f double dash c equals to 0, your second derivative fails. Means you cannot use your second derivative. So I can write here, second derivative fails. Then use first derivative to find maximum or minimum value. So can you remember what was your first derivative method to find maximum or minimum value? Just remember, the point x is 1. You take one value left to this, one value right to this. So what this is 0.9, this is 1.4. So x equals to 0.9. First we will take left value. Where we will put? We will put in the first derivative. So what is our first derivative here? Now f dash x, which is 6 into x minus 1 whole square. How much you get? F dash x, how much you get? Now 6 into 0.9 minus 1 square, that means positive, because square of any number is positive. Go to right hand side, then at x equals to 1.1, then your f dash x 6 into x minus 1 whole square, 6 into 1.1 minus 1 whole square, that is again positive. So there is no change of sign, neither in positive to negative nor in negative to positive. When there is no change of sign, it is no maximum or no minimum value. So if it doesn't change the sign, so it is no maximum or no minimum value. So therefore x is equal to 1 is called the point of inflection. This already I have discussed with you. If the derivative doesn't change the sign, then it will have the point of inflection, neither maximum nor minimum. So what did you conclude here? If your second derivative becomes 0, means at the point C, then your second derivative failed. You will go back to first derivative. Again I checked with the first derivative, it is not changing the sign. Not changing the sign means it has neither maximum nor minimum value. So that point x is equal to 1 is called the point of inflection. So more questions on second derivative we will be discussing in this chapter. So I will tell you, because the word problems which will be solving here, that will carry 6 marks in your board exam, will be based on your second derivative. So more and more questions will come on this, we will discuss in detail, and I am going to talk about what is called absolute maximum, absolute minimum value. Look at here. Absolute maximum and absolute minimum value. To understand this, let's see a graph. Suppose fx is defined in a closed interval. See, for local maximum, local minimum, you are taking the open intervals. Here you will take a closed interval. Suppose x equals to a. Let me make this graph little higher. One minute. This is x equals to b. So I have taken the closed interval. So obviously this will be your fa, this will be your fb. Then you are finding a point, the tangent here, point the tangent here, point the tangent here. So one value you will get here, one value you will get here, one value you will get here. From all this means including these two values and the point after putting f dash x equals to 0, this is your f dash c equals to 0, this is your f dash c equals to 0, this is your f dash c equals to 0. So you are getting one value of fc, one value of fc, one value of fc here. So we'll take all these values. From here we'll select which one is maximum, which one is minimum. So it's not that difficult. What are the steps you will have? Find first derivative of the function. So you can write 2-3 steps on this. Let fx is defined in the closed interval. Look at here, closed interval ab. Okay. Then what I have to do? Find f dash x. Put f dash x equals to 0 to find x is equal to value c. Suppose c, c1, c2, c1, c2, c3 like this. Then therefore x equals to which one? A, C and B in fx, not in the derivative. Directly you are putting in the function. Then find maximum or minimum value. Absolute maximum or minimum value. Okay, let's take one example on this so we can find out whether it is maximum or minimum. Let's take one question on this. Find both the maximum and minimum value of the function find both maximum and minimum value of the function fx equals to how much given to us? 3x to the power 4, then minus 8x cube plus 12x square, 12x square, then what you will get? Minus 48x plus 25, minus 48x plus 25 in 0, 3. That means when your closed interval is given, you have to think about your absolute maximum value, absolute minimum value. What are the steps? Find f dash x, put it equal to 0. So, what is your f dash x? Now, derivative of 3x to the power 4 minus 8x cube, 12x square minus 48x plus 25. Okay, 3x to the power 4 minus 8x cube plus 12x square, then minus 48x plus 25. How much you will get? Now 12x cube, 24x square plus 24x minus 48. Okay. So your f dash x equals to 0 implies 12x cube minus 24x square plus 24x minus 48 equals to 0. How to simplify? This is a degree of 3. I think you have studied factor theorem in class 9. So what I will do is, first let me take what is common here. 12 is common. It is x cube minus 2x square plus 2x minus 4. Okay, equals to 0. Now find, put a value where this will become 0. I think if you put x is equal to 2, if you put here, that will be 8. This will be minus 8. Getting cancelled. If you put 2, 4 minus 4. That means x is equal to 2 is a factor. So how to solve? I'll tell you the step. When x equals to 2, your f dash x, that is x cube minus 2x square plus 2x minus 4 becomes 0. You can check it. 8 minus 8 0, then 4 minus 4 0. So x is equal to 2 means x minus 2 is a factor. Factor theorem you recall from class 9 implies x minus 2 is a factor. So we have to divide this by x minus 2. So let's divide. So what is that? X cube minus 2x square plus 2x minus 4. Divide by x minus 2. Which number will go here? We will go with x square. X cube minus 2x square. If I subtract, this gets cancelled. Then 2x minus 4. Put 2 here. 2x minus 4. So how much I will get? So if I subtract, then it will be 0. So how much you got then? So your f dash x equals to 0 became 1 factor is 12 is already there, x minus 2, then x square plus 2 equals to 0. Okay, you got this? Now this implies x minus 2 equals to 0, x square, this implies x is equal to 2. The x square plus 2 equals to 0. So x is equal to minus plus minus root over minus 2. This is imaginary, so this is rejected because we are discussing about the real numbers. So you got x is equal to 2. Now you got, which are the values? X 0, then you got 2 you got here, then 3 because your interval was 0 to 3. So between this you got a point this. Where are you going to put? You are going to put in fx. How much you get? So what was your fx? Try to check. Fx was, our fx was 3x to the power 4, then minus 8x cube plus 12x square minus 48x plus 25. So if you put x equals to 0, first value, x equal to 0 in this function, you will get 0 minus 0 plus 0 minus 0 plus 25. So you got here 25. Then you will put x equals to how much? X equal to 2. Put x equals to 2. So 3 into 2 to the power 4, 8 into 2 cube, 12 into 2 square, minus 48 into 2 plus 25. You have to calculate here how much you are getting. This is 16 3 is 48. This is 8 8 is 64. This is 12 4 is 48. This is 96 plus 25. Achha, look at here. 48 48 is 96. You cancel with this. So what is left out? Minus 64 plus 25. Minus 64 plus 25. That is how much? 39. 39 you got. Then you would put x equals to 3. Put x equals to 3 now. So you get, if you put 3 into 3 to the power 4, 8 into 3 cube, 12 into 3 square, minus 48 into 3 plus 25. So how much you got here? 81 3 is 243. This is 243. This is 27 8. 216. Then 12 lines are again this gets cancelled. So how much I'll get? 243 plus 25. 243 plus 25 gives you 8. 268. 268, 216 you make minus 52. Okay. Now you choose which one is maximum. This is maximum. So fx is maximum value, that is 52 at which point x equals to 3. Then fx is minimum value, which is minimum. 25 is minimum at which point x equals to 0. So like this we will be solving some more problems tomorrow. Try to solve yourself. That is your exercise 6.5. We will continue tomorrow again.